Welcome to Challenge 9, where I will be displaying my workflow for translating this technical drawing into a 3D object in SolveSpace. This time we're given a wrench and we're only given one perspective of it. And what makes this different to the other challenges is that it has a lot of curves. But let's head into SolveSpace and give this one a go. There is a slightly different workflow which I did initially to try and get the shape of one of the sides, and that was to create a circle first and have another circle. You can see these two circles now intersecting each other, and to position these circles correctly we'll need to have an intersection distance here of 17 millimeters. But there is an easier way of doing it than that, than adding these extra layers of complexity into your workflow. And that is by sketching the parts that can be extruded together as best as you can. Let's do that now. If we step back for a moment and have a look at the technical drawing, we see that the wrench has three main components. It has the two parts at the end and a bridge holding those two parts together. Selecting the arc tool, I'll draw a semicircle and I'll give the diameter of this one 32 millimeters. Let me just reposition it over here and let's do the same thing again. So now I'll use the line segments tool and just connect these corners together. There is a horizontal constraint on this line and I want to remove this constraint because in a diagram this line isn't horizontal. So I'll click on the H and press delete. I want these lines to be equal and parallel, so I'll click equal and then parallel. And now I want to constrain the inner arc to have a diameter of 26 millimeters. As you can see, there's a lot of movement in this part here. So we can use guidelines to help constrain this shape. And I want these lines to be perpendicular to each other. So I'll select them and then click constrain to be perpendicular. I want the length of this line to be 17 millimeters. And we've got 4 degrees of freedom left. And we can constrain these lines to have the same length by selecting them and clicking constrain equal length. And we've reduced the degrees of freedom now to 3. And we've got a rotational degree of freedom. The angle now between this line and the horizontal x-axis is 17 degrees. And if you look carefully near the origin, there is an arrow here pointing along the x-axis and an arrow pointing along the y-axis. So I can select this line and the x-axis normal and then click constrain angle and type in 17. And now we've got 2 degrees of freedom, and that's because I can move the sketch in the plane. So let's anchor this sketch. So I'll select the center and the origin and click constrain point on point. And I can tidy this up a bit by dragging this to be here. Okay, so that's one end dealt with. You can just select the sketch you've just done and you can either go to edit and copy, or you can click Control and C, go to edit and paste transformed. And when you've done that, notice there's nothing in the actual sketch, but if you look in the properties panel, you see that we can do different things to it before we paste it in. And one of those things is the ability to rotate the sketch. Let's click on change for rotate and type in 180 and making sure that you hit return or enter on your keyboard and then click paste transformed now. And now I can click and move this sketch to be roughly where it is in the diagram. Let's just tidy this sketch up a bit. Now what we can do is constrain the arcs on the other side. This one's 30 and this one's 18 millimeters and this one has to be 13 millimeters, and we've got 3 degrees of freedom. Let's anchor this sketch with respect to the x-axis normal like we did before. So I'll select this line and the x-axis normal. You can just about see the yellow arrow highlights. Click on constrain angle and type in 17. Let's make these two centers horizontal to each other. And now let's constrain the distances between them to be 100 millimeters. As we're building up this sketch, you'll find that a lot of these measurements will take up some space. So in the properties panel, you can click here on hide constraints to help with your workflow. And now with 0 degrees of freedom, we can extrude this sketch by clicking here. And we'll give it a depth. We don't know what the depth is, but I'll just give it a depth of 5 millimeters. So I'll select one of the extruded axes and clicking constrain distance and type in 5. And now we can start a new work plane to create the bridge connecting these two pieces together. That's now our new work plane, and I'm going to sketch the bridge now. I'll start with 2 segment lines, and I'll join these line segments with an arc by selecting the arc tool and highlighting one of the semicircles first and clicking on the dots there. And to make sure that they're overlaid, you'll find that they're highlighted yellow when you put your mouse over them. For now, I'm just going to eyeball the sketch, but we will constrain it later. These 2 arcs have a diameter of 94 millimeters. So I'll do that now. And for the other one, I'll just say that they're both equal. And this arc has a diameter of 46 millimeters. And I'll just constrain them to be equal also by selecting the arcs and clicking here. As I drag this point, it eventually becomes tangent to the previous sketch. So this point has to be somewhere along this arc. And there's an easy way of doing this in SolveSpace by clicking on this button here. But in order for us to use this tool, we have to have 2 arcs in the same workspace. So I need an arc that represents this circle in this workspace. And the way to do it is clicking here again on the arc tool, and then clicking on these 2 points. I can constrain the diameter of this arc now to be the same as this one. And by doing that, you see that they're now overlaid over each other. That I've been able to overlay this arc over the previous one. And now I can use that tool to make sure that this arc is tangent to this one by selecting them both and clicking here. And you can see there's a T here to say that these 2 arcs are now tangents to each other. And let's do the same thing on this side. SolveSpace made that really easily for us. Before we do it on the other side, I'm just going to adjust these 2 arcs a bit. First, I need to say that the new arc on the other side is equal to this arc in terms of its diameter. So I'll select both of them and click constrain to be equal radius. And now we've got 5 degrees of freedom. We need to say that these 2 arcs are tangents to each other. And the same with these 2 arcs. And now we have 3 degrees of freedom. We've got some movement in the circle, but also notice we've got movement here. And that's because this arc needs to be tangent now to this line. So we'll select them, click here. Now there is a T symbol here. Same thing here. So let's do it over here as well. And now we've got 0 degrees of freedom. Now we're ready to extrude the model by clicking here. Turned red. Okay, to get rid of that, you just have to click on Force NURBS Surfaces here in the Properties panel. And let's just rotate the model. I'm clicking my middle mouse button here, by the way. And I want it to extrude the other way. But what I prefer to do is to constrain one of the extruded points to be flushed against this surface by clicking here, rather than typing in the distance. So if I go to Home, Hide All, and now that looks like we've got a wrench. This looks a bit weird there though, so let me just go back into the workflow and make sure that everything's okay in there. So I'll click here, and then show all, and yeah, I didn't constrain these to be tangents to each other. I'll just delete the constraints there for now, and here make sure that I've got everything right, and I want this line and that arc to be tangents to each other. Okay, I think that looks better. Another thing we learned there is that it's important to prioritize your constraints. Okay, let's see what it looks like now. Back in the properties panel, any changes I made previously will now have trickled down into the extrusion, and I can hide all again, and that looks okay now. I hope you enjoyed that. Let's move on now to challenge 10.